Hi, so today we'll be talking about polynomials. The formal definition of a polynomial is an expression of more than two algebraic terms, which consists of constants, variables, and powers. You have to make sure that the powers are greater than or equal to 0. Polynomial terms can be added, subtracted, divided, and multiplied, but they cannot have negative exponents and be divided by a variable. That results in a rational function as the examples below. Our first example is a basic polynomial expression, x squared minus 15x plus 56. This instance, it is a quadratic expression. One trick I've learned is to set each of these terms into a, b, and c. So x squared will be a, negative 15 will be b, and 56 will be c. To factor this expression, one other trick I learned is to find two values that multiply to a and c and add to b. So we result in 56 and negative 15. Two values that multiply to 56 and add to negative 15 are negative 7 and negative 8. After plugging in negative 7x and negative 8x in for negative 15x, split the equation into two pairs. So then you want to factor the left side and the right side separately. So you get x times x minus 7 minus 8 times x minus 7. This results in x minus 8 times x minus 7. The second example involves a topic called the difference in cubes. So we are given an expression with two different variables. We can see that 8 and negative 343 can both have a cube, 2 and negative 7 respectively. So the first thing you do is you remove 1 cube of 8x to the 6th and 1 cube of negative 343 y to the 15th into the first part. So it results in 2x squared minus 7 times y to the 5th. Then you see what value makes 2x squared multiply to get 8x to the 6th. That is 4x to the 4th. Then you do negative 7 y to the 5th times 49 y to the 10th, which results in negative 343 y to the 15th. To get the middle term, you multiply these two terms and multiply again by negative 1. This results in your final factoring expression. For the third example, we are given an expression with all terms having an x value. So after taking an x value out, this is similar to problem number 1. You factor each pair separately to get x times 3x squared times 3x minus 5 minus 4 times 3x minus 5, which results in the final factoring of x times 3x squared minus 4 times 3x minus 5. Now we're going to talk about general graphing rules. As polynomials get larger with more terms, graphing them can also become more difficult. Our first example is a quadratic expression, x plus 1 times x minus 2. So in the past we've learned how to find the x-intercepts and the y-intercepts and graph the parabola. However, now we can look at it as x plus 1 to the power of 1 times x minus 2 to the power of 1. Any term to the power of 1 will result in a single smooth curve. So if both of these terms are to the power of 1, we'll have two single smooth curves resulting in a parabola. Now for x plus 1 cubed, this results in an inflection point with a graph where the values are changing horizontally and vertically. This can also be seen in x times x plus 1 to the 2. So we'll take negative 1 as the x-intercept and x plus 1 squared, and we'll draw the parabola as seen in the quadratic example. And when we reach the x-intercept of 0, we'll have a smooth curve up, as seen with the power of 1. Finally, in a quartic function, we'll see that there will be x plus 1 squared times x minus 2 squared with two quadratic functions. So that means two parabolas. So that'll have a bounce off point right there, where we'll need two parabolas both facing up, resulting in a W-shaped graph. Using everything we've learned, now we're going to express it in one big problem. Given the expression 2x to the fourth minus 3x cubed minus 9x squared minus x plus 3, we need to sketch a graph also given one of the factors of the original expression, x squared minus 2x minus 3. In order to find the remaining factors, we need to use long division. Using long division then results in the second factor being 2x squared plus x minus 1. Looking back to example 1, we then use the factoring rules and factor both terms even more, resulting in 2x minus 1 times x minus 3 times x plus 1 squared. To further graph it, we need to first find the x-intercepts. So you get half, 0, 3, 0, and negative 1, 0. Using the graphing rules, we can then see that at x-intercept negative 1, it is squared, so we need to draw a parabola bouncing off at negative 1. However, we need to go back down to half, and 2x minus 1 is to the power of 1. So we'll have a smooth curve, single curve, and it goes back up to 3, which also has a smooth single curve up. This can also be seen as a quartic function, since the original function's highest degree was 2x to the fourth. And seen in the graphing examples shown earlier, a quartic function has two parabolas in a W-shaped graph, facing upward since it is positive.